Hello, this is Ruben Smith again. I just have put out one video, and this should be watched before you watch this so you can follow what I'm saying. But in that video, I think it was a little stuffy, but I thought it necessary for me to read my book word for word because it took me years to be able to present it like that. And I think it should be presented in book form. And I talked about gravity and how gravity was an action of a plane. These two-dimensional planes that are generated by the sun. It's held in shape, the spherical shape of gravity. Therefore, energy cannot leave the sun in a fluid-like way. It has to leave the sun in two-dimensional planes which have no mass. Therefore, they can penetrate gravity. And these two-dimensional planes are what makes gravity. And these planes have to be either parallel or at right angles because they're the same charge and they're trying to get away from each other. Anything less or more than 90 degrees on one side would be closer to the other. Far enough and they would collapse together, far enough apart, well, it'd be the same on the other side. They would collapse together. That's all explained in chapter 3 and 4, which I read in the previous video. Today, I'm going to read time compression in a gravitational field or inertia field. That's chapter 6 in my book. So here we go. Sir Isaac Newton thought of the universe as being like clockwork. Thus he presented formulas for force and gravity that are still used today. Albert Einstein came along and changed that with his theory of relativity, and that time was not constant but varies depending on gravity and inertia. This has been proven with satellites and superfast planes. Time has been proven to slow down in a gravity field or in an inertia field. Now, if we consider my two-dimensional fields as a source of gravity, we can have a clockwork-like explanation to the compression time. We can have a clockwork-like explanation to the compression of time in a gravity field. Now, see why I said I read chapter 3 and 4 word for word? Because if I don't, I'll stumble. That's why I'm reading it out of the book. If time is a measurement of change, let us look at the smallest possibility of change there can be. I described the field that makes gravity as being responsible for the pathways between the atoms. When this field comes into contact with protons or positive matter, it separates the protons from each other to form individual atoms. Remember that gravity works on each individual atom. Therefore, the smallest unit of time would be a single atom penetrating a single plane of gravity. If the atom penetrated 2 or 3 planes, we would have 2 or 3 units of change. Time can be measured by the number of these gravitational planes that are crossed. In the previous chapters, we discussed that gravity or inertia compresses these planes, causing them to merge. Being they consist of only 2 dimensions, there is no change in mass when they combine. This is why it takes an atom a longer time period to move an inch in a gravitational field or inertia field at the same speed than it would in deep space away from any gravitational force. Because in deep space it would cross fewer planes of force in the same distance. In deep space, away from a body of gravity, it will take less time to move an object the same distance at the same speed as it would on Earth. Let's do another thought experiment. Suppose an astronaut in a rocket ship was accelerating for space for 20 years, but according to the calendar, when he arrives back on Earth, 40 years have passed. The astronaut would have crossed more planes in any action he undertook while accelerating than he would on Earth. To him, it would appear less time had passed in space than did on Earth because of his acceleration, compressing the planes of gravity. Gravitational fields and inertia fields compress the fabric of time, but not of space. That is how 2 exact clocks can run at different speeds to an outside observer. The clock in deep space will appear to run faster than a clock on Earth to an outside observer because of the increase of planes of gravity in the same amount of area on Earth as the same amount of area in space. So time is measured by how many planes that you cross in the gravitational field. The planes compress in gravity or inertia, therefore you cross more in any action, therefore it takes you longer to move a mile at 100 miles an hour on Earth than it would to move a mile in space at 100 miles an hour. Thank you for listening, and God bless.